complex logarithm and complex powers. Alright, so today we want to look at complex logarithm and complex powers, and this is the last topic under algebra 151. That's math 151, which is algebra. Alright, so now to look at the complex logarithm, we want to first consider a natural logarithm. Now we have a natural logarithm. Let's say W is equal to the length of a complex number Z. If you have a natural logarithm, let's say length Z is equal to W, then W must satisfy Z, which is equal to E exponent W. So that is to say, anytime you have W is equal to like Z, then the W, E exponent, the exponent of the W is equal to what? Is equal to Z. The exponent of the W is equal to what? Is equal to Z. Why? Because the exponent of the W, if you find the exponent of both sides, exponent W, which is equal to exponent length of what? Of Z. Because the bases are the same, the exponent of the W will be equal to what? U of length. And okay, so let me write, since U of length is equal to 1, U of length of Z of any number A will be equal to what? The number A. Then we can say the exponent of the W is what? Is equal to what? Is equal to Z. Alright, sure. So now with this said, then we see that if you have Z1 multiplying Z2, if you have Z1 multiplying Z2, then we can say, that is to say, if you have Z1 is equal to E exponent W1 and Z2 here, which is equal to E exponent W2, from this relation, then if you want to multiply Z1 and Z2, it will be E exponent W1 multiplying E exponent what? The W2. And per law of the exponential functions, we say if the bases are the same, we add the exponent. So we get one of the E, which will give W1 plus what? Your W2. And if you want to take log, taking log on both sides. So from here, we want to take log, that is from this equation, we want to take log on both sides of the equation. So if you want to take log on both sides, then what happens here is that if you have length of what? Z1 multiplying Z2, then it is equal to what? The length of E of what? W1 plus W2. And the length of E, which is W1 plus W2, is the same as what? Take note, I said E exponent length or the length of the E is the same thing. I get it. So it is equal to W1 plus what? W2. And if it is equal to W1 plus W2, what is W here? It is length Z. So that means W1 here is equal to the same as what? Length Z1. And the W2 here is the same as what? Length Z2. So that means the W1, W2 is the same as what? Length of what? Z1 plus what? The length of what? Of Z2. So anytime you have length of Z1 times Z2, it is the same as length of what? Z1 plus the length of what? Of Z2. Alright. Now we have already noted that the argument of a complex number is what? Multivalued. I get it. The argument of a complex number, we've already noted that this argument of a complex number is multivalued. Okay, so multivalued in the sense that the argument is now theta plus 2n pi. So first, we already established that the angle that we got when we raise this, that is the polar form of the equation, which is equal to E r I theta. That we said the r here becomes the modulus of the complex number, and the theta here was the argument of the complex number. Because of some reason, due to their same rotation, we said the argument can also be what? Multivalued in this form. And now if it is the same, then you rewrite the polar form of the complex number as REI into bracket theta plus 2n pi. So we established this part in the previous video. Now, if you have the complex number in this way and want to take log on both sides, taking log on both sides, want to take log on both sides of this equation, what do we get here? We can say then our length of the complex number z is equal to what? Length r plus length of complex number z is equal to length r plus in logarithms when there is multiplication. You want to introduce logarithm is what? You bring your plus, which is what? Your length of what? Your e exponent I into bracket theta plus 2n pi. So this will be the expression now. Now to simplify this expression, you can have your length z, which is equal to what? Your length of what? R plus. Now since you have a length and an e, means you already take what? The exponent. Are you getting it? You've already established that fact. So now it becomes I into bracket theta plus 2n pi. And this is how, when you take the logarithm on both sides of a complex number in its polar form, this is the expression that you are expected to get. Okay, now with this, let's look at two concepts here. All right, so let's look at 2 points here. One, we want to evaluate length of negative I. We want to evaluate the log of negative I. How do we go about this? Now, before we can start, let's rewrite the length of negative I. So upon rewriting the length of negative I, we get length of e exponent I into bracket the angle theta, we take it as minus pi on 2 plus 2n what? 2n pi. So we are rewriting the length of I in terms of what? This exponent. In terms of this exponent. In terms of this exponent. Okay. And now when we do this, what do we get here? That is the length of negative I. So when we do this, what we get here is that what we can get at this very point here is that this and this will now be equal because of the length, and then we can only write the exponents, which will give us negative what? I pi on 2 plus 2n what? 2n pi. So the length, that's I pi on 2 plus 2ni. And when we get this, we can say hence our length of negative I, our length of the negative I would then be equal to negative pi on 2, comma 3i pi on 2. So you can say our length of negative I is now equal to negative pi on 2 and 3i pi on 2. 3i pi on 2. That is when you evaluate this particular thing. This is what you will be getting. And now the principal value, after dealing with this, the principal value of length I, the principal value of length of negative I, length I, is given by length I, which is equal to negative pi on what? 2. So the principal value of the length of what? Negative I is given by length I, which is what? Negative pi on 2. And this is how we evaluate what? A log of what? A negative I. A log of what? A negative I. Let's look at the second example. Alright, so we want to look at this second expression. And the question says that we should simplify the expression. Okay, so let me write it here. Simplify the expression, z is equal to I exponent negative 2i. This is the expression that we have been given here. and you are asked to simplify the expression. So what are we going to do here? First of all, we want to find the logarithm of both sides. So you have ln of z, which is equal to the ln of what? I exponent negative 2i. And per laws of logarithm, anytime you have something of this nature, log a exponent n is the same as what? M log of what? The number e. Okay. So now from here we can say ln z is the same as negative 2i ln of what? Of I. So we take the exponent and multiply by the logarithm of what? The number. And now, if we have to imply our inverting process over here. We have to imply our inverting process over here to take away the logarithm. So implying the inverting process, we use our exponent. So our exponent of the ln of z, which is equal to our exponent of what? Negative 2i ln of what? Of I. Negative 2i ln of I. And our e ln of z is the same as z. So our e ln of z is the same as z, which is equal to e negative 2i ln of I. Now what is I? What is the ln of I? From previous videos, we've established the fact that if you have I can also be written as e exponent I into bracket e exponent I into bracket pi on 2 plus 2n what? Plus 2n pi. And that's in previous videos what we've established. In previous videos, this is what we've established. So now, if you want to take ln of both sides, we can have ln I, which is the same as what? Ln of what? Of e exponent I into bracket minus pi on 2 plus 2n what? 2n pi. And now when you do this, because of the ln and the e, you already equate the exponent. So therefore, our ln I now will be equal to what? Sorry, now will be equal to I into bracket pi on 2 plus 2n what? Plus 2n pi. Will be equal to pi on 2 plus 2n pi. Alright, so this is it. Anytime you have I, it's equal to pi on 2. It's not negative, so take note, it's not negative, it's positive. Alright, so this will be it. So now we can put our ln I over here in this equation. Sorry, in this equation. So now we know that our z already is also equal to what? I exponent what? Negative 2i. Which is I exponent negative what? 2i. So therefore, our z in this equation here is equal to e of 2i ln I. We can say I exponent negative 2i is equal to e 2 exponent I. And what is our ln I? Our ln I here is this value, which multiplying what? I into bracket pi on 2 plus 2n what? Pi. Okay. So now our I raised to the power negative 2i in simplification will be equal to e exponent negative 2i squared multiplying pi on 2 plus 2n what? Pi. So now per laws of indices, because it's multiplication here, we can expand it. Okay, so let me just take it slow for you guys. So let me just expand this one to we get e of negative 2i squared multiplying pi on 2. Multiplying pi on 2 plus I getting it. Multiply pi on 2 plus negative. Also, let me just take it this way. Negative 2i squared multiplying what? 2n what? Pi. Okay. So now this is it. Now when you get this, what happens? When you get this, what happens? So we can have e exponent. Take note that I squared already is what? It's negative 1. So if I squared already is negative 1, it will affect this one. So negative 2 times negative 1 will be what? 2. And these two cancel these two away. So we get u of what? Of pi. We get u of pi. And what will be this over here? This is also negative 2. I squared, so that will give you positive. That will give you 2 here. 2 times 2 will give you 4. So that will give you plus 4 and what? And pi. plus 4n squared, and this will be the solution after you are done simplifying this particular expression. So now what happens here is that you realize that with this very solution there is no imaginary part because there is no I. There is no imaginary part in this equation. So since there is no imaginary part, this equation is actually a real quantity alone. This equation is actually a real quantity alone rather than a complex number. It's a real quantity alone rather than a complex number. Thank you very much. Let's meet in other videos.